the analog pin, right? The first analog pin of Arduino, and I will mark it with a different color. Let's say I mark it with gray. Okay. So that is the circuit connection of this temperature sensor with the circuit, right? This is all that you have to do in the circuit connection, right? So if you remember the steps, that is power with the 5 volt over here of Arduino, and then this ground with the ground, and then this V out, the voltage output will be connected to A0. You can connect it with any of the analog pin, but then the coding will change, right? Over there, you will just have to, instead of A0, you will have to mention any other port, right? So I will show you the coding also. So for that, what you will have to do, first of all, you'll have to remove this. I'm just removing it for, there will be confusion. So this is a comment only, so don't need to worry. So what is a comment? Comment is just a statement that doesn't get executed in the code. Okay, let's say this include the library code. So this is a comment. Why it is a comment? That there are 2 backslash, right? So it will be highlighted as brown for the comment. Okay. So now what we will do is I'll just, move everything, and I have the code already. So what I'll do, I'll just go on to this code, and you can also take the screenshot of the code, as it will be not be available to you in any other way. So let me just take it to the full screen. So this is the code. So students, you can just take the screenshot of this code, and then you will have to write it in a similar fashion, right? When you will write it in the code of the Tinkercad, right? Then you will get the similar output. Okay. So just take the screenshot, and the way I have written the code, just, write it accordingly. I will also share it on the Zoom meeting, but the chat. But the problem is when you will just, copy and paste it from there, it will not be pasted in a correct fashion. So you will be getting error. So what you do, you just take a screenshot. Okay. I hope students, this is an important screenshot. You must have taken it. You can just type yes, we have taken it in the chat box, so that I am able to know. Okay, yes, you have taken. Okay. So what I'll do, I'll just copy paste it from here, and I will also explain you each line. So don't worry that what does this code mean actually. So what I'll do, Control plus C, Control plus V. Okay. So we have this code over here. Now, what does this code mean? Okay. So first of all, I will start with line 1. That is #include liquid crystal.h. So basically liquid crystal is a library. Okay. We are importing a library. So what is the function of a library? Let's say in your school, you must be having a library, right? So there are some pre-written functions in this library. Let's say for liquid crystal, this liquid crystal is a function right over here, or let's say we have this set cursor, begin. So all these functions are already there in this liquid crystal. Okay, so that is why we don't have to make a long code. It shortens our code, right? We take help from the library. Let's say you have to gain some knowledge, so you go to the library to issue a book, so you gain knowledge from there. In similar fashion, we have this library called liquid crystal.h. Okay. Okay, so now comes this third line, that is, it is a comment, right? 2 backslash are there. Initialize the library with number of interface pins. So liquid crystal LCD, these are the interface pins. Okay, so this same command was there in the previous code also of the basics. So it is saying 12LN 5432. Okay, so when I take it over here, so we have 1211 that is connected to RS and enable. And then 5432 is connected with the DBs 4 to DB7. As it is a 4-bit mode that we are talking about over here. I just explained you 8-bit mode and 4-bit mode. So this is a 4-bit mode in which DB4 to DB7 pins are used. Okay. So we have written this over here. Then comes this #define pin temperature to A0. So we just did it over here. You see this voltage out, we have connected with this A0 analog pin 0 of the Arduino. So for that purpose, we have defined it, right? Now comes this void setup. Void setup is just we are, assigning role to a pin, right? Let's say we connected this 5, or let's say in the pin over here, the pin mode, right? We have to set up, right? So for that purpose, we use a void setup. So over here we will be writing serial begin 9600. So it is just for the serial monitor to begin. Then comes the pin mode, pin temperature input. So basically we are getting an input from this temperature sensor, right? No, you can do it later on, but just you have to remember it how I have just connected, right? So you will be able to take a screenshot of this circuit. If you want, you can just take it right now. Okay, you can just take the screenshot right now and make it, afterwards. I will just explain the circuit. So you just, go on with my explanation. I hope you must have taken the screenshot. So I will come back to explanation. So over here we had the voltage 0, right? With the A0. So in the code, you will see it is getting an input, right? Pin temperature. So when I will start the simulation, I will show you how, we can change the input by pressing it. I will just show you. Then comes this LCD begin. LCD begin 16,2. So it is the similar fashion that we saw 16:2. So it is just for explanation that it is having 16 column and 2 rows, right? The comment is also there. Set up the LCD number of columns and rows. Okay. And then we have to print today's temperature, right? So in the previous circuit, you saw hello world. So what I have done, I've just removed it and, written today's temperature. Okay. And then comes the void loop. It is the function that has to be repeated again and again. So over here, what we have done, float temperature. Float is a data type for decimal values. So we'll be having a decimal temperature, right? Let's say 24.7, 24.8. Let's say we have a decimal, right? So over here, for that purpose, we have used a float temperature. Then we have an analog reading, pin temperature. So this is just a function for this A0, right? That we are having an analog reading. So for that purpose, we are using this function. And then there is a calculation. So what we have done is this 5.0 is the voltage. So we have 5 voltage and we have divided it with 1024. So the analog reading in an Arduino over here, it is from 0 to 1024, right? So for that purpose, we have divided each voltage from this 1024. So when I will just, slide this temperature sensor for the reading, we'll get a different reading on this for this LCD. Okay. So for that purpose, there is the mathematical operation. So try to do it, from the screenshot, like the way I have done it, because then you will have error. Okay. So now comes this LCD set cursor. So this is also a function of this library only. Okay. So this set cursor means 0, 1. So it is a coordinate. Okay. 0, 1. So what it will be, the 0 will be the column and 1 will be the row, right? The way I showed you on my screen, right? When I was giving you notes. So remember that, and I will show it to you on the screen also. Then comes this LCD print. It is basically used to print the temperature. That temperature we have got it from here, right? This temperature, TEMP. Okay. So TEMP. So we'll be having that temperature. Then we have the serial print ln temperature. So basically, if you see in the serial monitor, so for that purpose, we have taken this serial print ln. And then we have given a delay of 1000 millisecond. 1000 millisecond is equal to 1 second only. Okay. So we'll be having a reading just after 1 second on this serial monitor. So let me just start the simulation and things will get be there. So when I start the simulation, you will see over here, it is written today's temperature. Okay. So the temperature is not coming in the full because the boxes are small. So let me just, what I do, I just remove this today's. Okay. I will just write temperature. Okay. So you will be able to do it. It's not a big deal. So over here, you will see temperature, then 24.71. How we are getting this temperature? Over here, when I tap it on the temperature sensor, you will see 25 degrees Celsius written, right? So it gives a little bit slightly not exact value. It is just because we get errors, right? So when I take it to minus 40, that is the minimum temperature it can measure. So it will give minus 40.23. When I take it to its maximum, so it will give 124.8. Okay. So you can take any value that is according to the surrounding. You can play around with it and you will get a reading over here on the LCD screen. Okay. So if you can see, I will show you the code also parallelly. So you get this temperature that are highlighted over here on the first box. Okay. So it is printing, and also if you see the serial monitor, so we are getting the values according to the one that are shown on the LCD, right? 24.71, 24.71. When I decrease it to -40, over here you will see there is a change in the serial monitor also. And we are getting it after a delay of 1 second. How we are getting it? If I just show you over here, we have a delay of 1 second, right? And one more thing, what I wanted to share with you, if I just remove this ln, right, after print ln, we have this ln. So any student can tell me what will happen if I remove this ln over here? Any student, you can raise your hand if any student knows, or else I will show you what happens, because this is important. Okay, no student. So what I'll do, I will just remove this ln. Okay, let me stop the simulation first, and let's clear this. When I will remove this ln, what will happen is, let's start simulation. You will get the reading in the horizontal manner. Okay, so we have 24.71, then 24, same reading, but in a horizontal manner. So it doesn't seem good, right? So we have to see the reading in a vertical form so that it is visible and clearly convenient for us to understand, right? So it is very much confusing, right? So for that purpose, we use a ln. Okay, so I write ln. I will have to stop the simulation, write ln. And then when I start the simulation over here, you will see we'll be getting a vertical reading. Okay. So for this purpose, we use this ln. So I hope students, you got a fair idea about this circuit, digital thermometer. You can again